How often do you look at pictures of space from telescopes? No, not that one, more like this one, Hubble. Most people like how pretty telescope images are, but there's also a lot of information to gain from these pictures. For example, using spectroscopy, described by HubbleSite.org as the study of the spectra produced when material interacts with or emits light, is a big way that scientists can learn about a celestial body's properties. For example, what elements are found in a certain star being observed. The color that a telescope receives is broken down into a spectrum of component colors, just like a prism shows you the rainbow when sunlight goes through it. However, there are ways that these spectral lines can be shifted. If you're a space enthusiast, have you ever heard of the term redshift? Hi, my name's Snigdha, and today I'm going to be explaining the different kinds of redshift, along with a few ways that redshift can be interpreted and used by astronomers. First, what is redshift? I think about redshift as the way the wavelength of light becomes longer for the observer, causing the way we perceive that light to change. The first type of redshift is called Doppler shift because it's related to the Doppler effect. Basically, the Doppler effect describes how the motion of an object affects the observed wavelength. Light moves at a constant speed of around 300 kilometers per second, and if the object emitting electromagnetic waves and light, such as a star, is moving away from you very quickly, the wavelength you observe is longer than it would have been if the object were stationary. The Doppler effect happens with sound waves as well, but our ears would perceive it as a lower or higher pitch instead. With light, our eyes perceive changes in wavelength as color, so if the wavelength is longer, it seems more red. This is why the phenomenon is known as redshift. If the same object were moving toward you very quickly, the wavelength would be shorter, so we'd perceive it as bluer, moving to the other side of the color spectrum. This is called blue shift, but sometimes both situations are referred to using this general term redshift. The second type of redshift is known as cosmological redshift. Instead of being related to the observed object's motion, it's related to the expansion of the universe. As the universe expands, the wavelength of the traveling light stretches as well, causing it to look more red. This diagram I found online explains it pretty well. Cosmological redshift is used by astronomers to estimate celestial objects' distance from Earth. They do this using the formula Z equals observed wavelength minus emitted wavelength divided by emitted wavelength. Z represents cosmological redshift.